Hi friends, so today we are going to see the minimization of automata, right? So the title is equivalence and minimization of automata, right? Okay, well, there are some steps for converting uh, the automata into a DFA, minimized automata, right? So the steps are the two languages are equivalent if they define the same language. So when the two languages are equivalent is it defines the same language. If the two languages expresses the same language, it is said to be equivalent. Expresses the same strings, it is said to be equivalent. Second point is reduce the number of state in a given finite automata, that is redundant state. So we need to reduce the states. If in a transition table we just find any two state having the same transition, we consider that two states are equal, okay, equal, and we just delete any one state, right, and just delete one state and proceed with the remaining states, right, because we reduce the number of states in a given automata, that is redundant states are to be reduced. Next, use iteration table to find which two states are equivalent. Okay, so the iteration table shows to find out which two states are equivalent, right? So we periodically update the transition table, so that transition tables are said to be iteration tables, right? Then the two states are equivalent if both states having the same transitions, right? Same as the first one. If both the states reaching the same state for a same input alphabet, then the two states are said to be equal. So here, if for example, if both the states reaching a same final state, right, final state. So if 2 be the final state, if 1 on A goes to B, right, then if 3 be the intermediate state, 3 A goes to 2, then 1 comma 3 are equivalent. If two states having the same transition A, which are reaching the final state, then the two states are equivalent. Likewise, if for example if 2, if 3 be the final state, for example A, B, right, then if 3, for example 4, okay, so here, so 1 comma AB goes to 3, 4 comma AB goes to 3. So now 1 comma 4 are equivalent. Understood? So if 2, so likewise we calculate. We just proceed to minimize DFA for the minimization of DFA. So 1 comma AB goes to 3, 4 comma AB goes to 3. Now 1 and 2, 4 are equivalent because for AB it goes to the same state. So now 1 and 4 are equal. We just do the sum, following sum according to these rules only, right? So first sum is construct the minimal state DFA for a automata. So these are the given transition table for the given automata, right? We just convert the given automata into a transition table so that we can perform the sum easily. These are the table. We just find which two states are equivalent, that's all. So we just find which two states are equivalent, which transitions are equivalent, and we just eliminate the redundant states, right? So in the solution we need to find the equivalent states. So in the above transition table, b comma 0 and b comma 1 goes to GC, and c comma 0 c comma 1 goes to GC, right? So b the state b on input alphabet 0 comma 1 goes to GC, c the state c on input alphabet 0 comma 1 goes to GC. Now both the b comma c having a same transition, so both are equivalent states. So now we just change the transition table like this. So wherever we find B, C, we just change as BC. right? So BC, so BC, so wherever we find B C, we change as BC. So BC, 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 right? So another we just having C column also. So B is C. So we just eliminate any one state because these two represents the same transitions, right? So if for example, if we BC, BC, G, C, GC, so both state shows equivalent after transitions, right? So we just eliminate any one state. Okay, well, we just proceed in this manner. So we just eliminated the C part, another one part. Okay, now BC. So wherever we find BC, we just change as BC. Likewise, after iteration, after the modification of the transition table, that is iteration table, we check if whether any equivalent state exists or not. So again find the equivalent state if possible. So for example, del of d comma 0 goes to BC, del of d comma 1 goes to G. Likewise, f comma 0 goes to BC, transition of f comma 1 goes to G. So these both are equal. So d comma f are equal. Likewise, so d on 0 1 goes to CB, d on goes to G. Likewise, df f on 0 goes to BC, f on 1 goes to G. So these both two D and F are equal. So D comma F are equivalent states. So we just wherever we find D F, we changes DF in the left hand side also and the right hand side also, right? So DF, likewise here we are having F, we just change as D. Likewise F D. Okay, wherever we find D or F in the transition table, just change it as DF, right? Okay, now check B comma C. So after modifying the table, again check whether there are two equivalent state exist or not. So we find right. So now check B comma C and H having the same transition. So these and H having a same transition. So B comma C and H states having a same transition. So 0 on getting G, B comma C and 1 getting B comma C. So likewise G, B, C. So both B comma C and H are equal. So we just change B, C and H as BCH, right? So wherever we find BC, change it as change it as BCH. Wherever we find H, change it as BCH. Likewise, we just change the wherever we find, just change it as BCH. After modifying, we are getting this transition table. That is, these are one of the iteration tables. Now from the above transition table, we again serve if any equivalent state exists or not. Again we just find A comma E are having same transitions. So A comma 0 getting BCH, A comma 1 getting DF. Likewise E comma 0 getting BCH and E comma 1 getting DF. So just we now change the wherever we find A, we just change it as AE. Wherever we find E, change it as AE. Likewise we just change and we eliminated the redundant part. So for every iteration table we just eliminate the redundant part. So that is the rules of our rules to minimize the DFA. So after getting the final transition table, just check whether any equivalent states exist or not. If there is no equivalent state, then these are the minimized DFA, right? So uh, after the final iteration table, just convert the transition table as a minimized DFA form. So these are the minimized DFA. Okay friends, understood? Thank you.